Welcome to week 13 of our Intro to Programming course. So in week 13 we're going to be moving away from loops and arrays into a conceptually somewhat easier domain. We're going to be talking again about how to design classes, and so now you're going to be learning some rules for good class design. How do you pick classes? How do you design methods? And so the focus is on having more than one class, on having several classes that collaborate with each other. In the homework you're going to be seeing this. There is one example where there is a class for a projectile and a class point, and the projectiles have locations that are points. There's another example of a grade book that has collections of students in them. And actually that homework is going to show you two different ways of doing it. One that's more object-oriented and one that's a more traditional stepwise refinement approach. And then next time I'll talk about a little bit on which one of them might be better or how they're different at any rate. But what I really wanted to do today is pick up something from the exam where we had this walkthrough problem. And I was a little disappointed that a good number of people tried this problem and must have spent a fair amount of time on it, and then they didn't get it right at all and lost a bunch of points on it. So I'm just going to go do this walkthrough, and I'm going to do it in two ways. One is the more traditional way that you'll find in the books, the compact way, and then the more drawn-out way that I asked you to do in the exams, so that I can know in which order you filled the elements and so that it's easy to grade. So it is really important that you can do these walkthroughs. A walkthrough shows whether you can understand what the computer does. And if you can't understand what the computer does, then you can't really do any programming. I mean, it's just impossible to tell the computer what to do if you yourself don't know what that telling is going to entail. So I'm just going to do this here in excruciating slowness. If you know what I'm doing, just you can tune out now. There's nothing else coming in this video. So the sample input that I had here was bandanas. And that was in str. So I should really be putting my variables up here. Then we had max, result, ch, count, and j. So I'm simply going through here and looking at all of these variables. Here was str, here was max, here was result, str already had, here's ch, count, and j. That's all the variables I had. There's supposed to be a total of 6. Alright, so now I'm going to go through this method here, a line at a time, and I'm just going to be putting that red cursor where I currently am. If you had this on a sheet of paper, you might be using a paper clip, but if you do this in an exam, the cursor is as good as anything. Just make sure not to unnecessarily move it. So it says int max equals 0, so I'm going to put a 0 in here. So when one does this on a sheet of paper, one just kind of puts the numbers anywhere where they reasonably fit. If I had done this for the exam, I would have had to be careful to put it here into the next row. But like I said, I'll just first show you how you're normally going to be doing this. This is an activity that you don't just do in exams, but that you do a lot of times. Alright, so back here, result is the empty string. Now, does str have a length of greater than 0? Sure, it's long. So we go inside here. Ch is the substring from 0 to 1. That's the letter B. So notice that this involves absolutely no guesswork. All you do is you walk through one line at a time and you figure out what does this line do, and you write it down. Moving to the next line, count is equal to 1. I don't know why it says so, but I'm just doing it. J is stir.indexOf ch, 1. What the? So if I look at str, it's here, and ch is the B. Now index of gives me the index of the b? Well, that would be 0, the initial index. But wait, I have to start at 1, so that one doesn't count. So now I have to know a little bit about index of, because the b is not found here in this tail. That means the index is -1. So that means j is set up to -1 right off the bat. All right, now j is -1. Now with a for loop, you now have to know that next it executes the condition here. So now it checks, is j not equal -1? Well, it is -1, so I'm not entering the loop. Now it says is count the same as max? Well, let's see, count is 1, it is not the same as max. So I'm not entering this. Is count greater than max? Well, count is 1, max is 0. So yes, it is. So result is ch. So result now is the string b. Max is count. str, I'm replacing the b with the empty string. So that's now Andanas. Now I'm here at the end of the loop, so I have to go back to the top of the loop, up here. Is str.length greater than 0? Yes, it is. Now this is the first letter, so ch is an A. Now count is 1. It was 1 before, it's 1 again. I could write it or I could not. Now j is the index of A in this tail thing here. So that would be this position here. So I have to count 0, 1, 2, 3. So j is 3. And now what happens? Now I enter the test. Is j not equal -1? Well, it's not. So I'm inside here, count plus plus, so count is now 2. Now I'm going to the update condition of the loop. You do have to know that to do the tracing. So that's the update condition here. And so j is set to the index of, let's see, what was j? J was 3, so it's the index of from the 4th on. That means that we're looking here, and now we're trying to find, is there another A in here? And indeed there is. And so that index is, let's see, if this is 4, 5, 6. So at this point j is 6. And what's next? We enter the loop. So count is 3. And now we go to the update condition, which is this one here. And so now j plus 1 is 7. And so we're supposed to find the index of the next A at offset 7. There is none anymore. And so now j is -1. Now it is this -1 here that only a small handful of you have answered in the exam. J does assume the value -1. If you follow through what happens when you go through a for loop, after the end of every iteration of the for loop, that update is executed. The update says j equals stir.index of ch j plus 1. It happens. And when it happens, it really does set j to -1, and you have to write it down. All right, so j is -1, and it's in fact just that having it to be -1 that makes us break out of the loop. So now the next thing is count equal to max? Let's see, count is 3, max is 1, so it's not. So that means this part doesn't happen. Is count greater than max? Yeah. So result is ch. So that means whatever it was a b here before, and now it's an a. And max is count, so max is now 3. Now in str gets changed, so we change it to a string that gets all the A's replaced by spaces. That is NDNNS. All right. So we go to the back of the loop. That string is still greater, the length is still greater than 0. We now look at the first letter in it. That's an N. We set count equal to 1. We set J to the index of the first N after the first one. That's the one over here. That would be 0, 1, 2. We do count plus plus because we go inside the loop. We now update J here. It's, okay, J plus 1 is 3, so we're looking at 0, 1, 2, 3. The first N greater at index greater or equal to 3. Well, there is one at position 3, so J is going to be 3. Count gets incremented. Now J gets to the first index of N after 4. There isn't one, so J is again minus 1. That gets us out of the loop. So now let's see, count equal max. It does this time because max is 3 and count is 3. So we're supposed to say result equals result plus CH, so the result changes to AN. Then we don't get into here. Now replacing all of the N's with nothing. And so when you do that, you get DS. Now that gets us back here. The length is still greater than 0. We get CH to be D. And now this is getting intensely boring, and I'll leave it for you to finish it. But the point that I want to leave you with is that it is completely and utterly mechanical. As long as you, the only two hard parts here were to understand index off. You have to understand that index off, what it returns, the next position that's after whatever this argument here was, and you have to understand it gives you a minus 1 when it didn't find it. And the other thing you have to understand is how the for loop works. That the first time you enter the for loop, the first time and only the first time, this condition gets executed. Then it moves into the body. I shouldn't, actually that was wrong. It doesn't yet, because what it first does is it checks the test. Then it moves into the body, and at the end it moves into the update, and then it moves again to the test. So you have to understand that sequence, otherwise you can't trace through a for loop. So if you know those two things, how index off works and how the for loop works, the rest is just mind-numbing boredom of doing this thing one step at a time and not losing track of where you are. And so the values just come out like that. In the final, you'll be getting one like that, and you simply have to go through the mind-numbing activity of tracing it a step at a time. So like I said, in an exam situation, the way you're supposed to be writing, it's a little bit different, because as you can see here, if you had to grade what's written over here, you'd have no idea in which order these things came. I just wrote them in pretty much wherever I found space, and sometimes I crossed things out and sometimes it didn't. That's just the way one does this if one needs to trace code and find out why it didn't work the way that one wanted it to, or how it worked, or whatever. And so in an exam, you simply have to write every update into a separate line. I'll just do that so that you see it. So when we start afresh, we'll write the variables that we want on the top. That's just 1 right now. Now, then here max is 0, so you put that on the next line. Then result is the empty string, you put that here. CH is the initial string, that's the B. Count is 1. J is the index of the B, that's a minus 1, there wasn't one in there. Now result is the B, so that gets us into here. Now stir gets replaced with the rest here, And as you can see, now because everything is on a separate line and they're all nicely spread out, and you can really see which variable got set before which other, and then it becomes easy to grade. And otherwise I'd have to take a movie of everyone doing the handwriting, and this way I get something where I can see that you did everything correctly and in the right order. So do that on the exams, but don't do it when you do it at home. That's, it just spreads the thing out enormously. When you look at my solution that I handed out, it goes over 2 pages. The other thing is, what about these x's when the variable goes away? So I didn't do that in the walkthrough because normally we don't really care about that so much when we want to find out what some piece of code does. That's just an extra thing to see, do you understand how local variables work? And there's 2 sets of local variables that act differently. Over here in this for loop, you have this variable j, and it goes away at the end of each loop. So when we exit the loop here, then the j goes away, and we put an x in here. And then the next loop, what that gets entered, where j assumed the values, what was it, 3, 7, and -1, I believe. Then afterwards, you'd again make an x when it goes away. And so it had some other values that I now can't remember. And then there was another x, and then there was another -1, and then another x, another -1, and another x. So each time the variable j goes away when the loop exits, and it gets recreated when the loop gets re-entered. Then let's see, what other variables do we have? These ones here are local variables to this outer loop. At some point, after dozens of steps, this outer loop will have exited, and then ch and count go away. They really go away at the same time, so what one normally does is one puts these 2 x's here next to each other. And then finally, after that happens, we have this return statement, and then the other variables, max, result, and the parameter variable get done away. So you'd put these x's here. All right, that's how you do the tracing. So I will put out some practice exercises for this before the final, and it is totally essential that you know how to do that. In the meantime, whenever you go to Piazza and you will see some kind of a mess of code like this, and then someone says, gosh, it doesn't really seem to be doing what I wanted to do, what you can always do is you can actually trace through this. Now with a quadruple loop, that's probably at the outer limit of patience that anyone has. But even if you just start tracing it through, you often see right away what goes wrong, because it doesn't usually take very long to get to the point of error. So anytime that your stuff doesn't work the way it's supposed to, just trace through it, and there is an excellent chance that you'll find the error. If you can't find it by tracing, the next step is, of course, to use the debugger. And maybe next week or the week after, I'll make a movie out of that when I have a really good example on where that would come in handy.